Okay, good afternoon, everyone. My name's Ron Weinstein. I am a senior specialist solutions architect manager here at AWS, and that's a new title, and it's kind of a tongue twister. But what that means is I have one of the coolest jobs I think you'll find anybody here at the conference, maybe with the exception of those here in this room. I get to go across the public sector, specifically in the US government, and talk about how advanced technologies like generative AI, like analytics and databases and advanced analytics, and even things that are a little further out, like quantum technologies and things that are today, like HPC technologies, our customers can use to advance their mission. And I'm excited to be here today to tell everybody about generative AI specifically and kind of thinking about it in the context of regulated workloads. And I'll tell you in a couple seconds like why I have a corgi up here. But before I do that, I wanted to just kind of pull the audience a bit. So who here has played with generative AI in their workplaces? I know a lot of us kind of have done it. Cool. Who is a production generative AI application that they or their deployer use? A couple. How about regulated workloads? So I think regulated workloads is things like financials, healthcare. Most government applications have lots of regulation. Who works in kind of a regulated environment? I'm going to guess that's pretty much the whole audience. Okay. And what we'll talk about today is deploying Gen AI with that regulated environment kind of hat on. How can we do this in keeping with the regulations, in keeping with the rules and compliance restrictions that we have in our organization? So we like to have fun with generative AI, or at least I and my team like to have fun with generative AI. And we like to use corgis here, or dogs, as ways that we can kind of have fun a little bit. Corgis specifically at Amazon have a little bit of meaning. The first corgi at Amazon, his name was Rufus, and he was back way when Amazon was in the business of, selling books, not in producing movies and cloud computing environments and stuff. And what Rufus's job is when they released a new version to the website, they would take his paw, hit the enter button, and all of a sudden it would be deployed. So we've kind of taken a riff on that a little bit, and we like to kind of experiment with some of this image generation and some of text generation with Gen AI, having fun with images and text. And we'll kind of infuse that a little bit into our talk today and talk about the ways that that's actually helped us learn. I'll be going for maybe about 25 of my 30 minutes, depending on how I like to talk, and I'll leave some time for questions at the end. I'll also stick around afterwards if you have any questions for me. Okay, so let's get into it. What we're going to talk about today is evolving kind of generative AI for these regulated workloads. Our kind of path, if you'll bear with my analogy here, our path in this evolution are what we call disruption landscapes, right? We know this technology is very disruptive. We know that this technology can do a lot of things for a lot of different places within our industries and places within our mission, but it can be tough when we have regulations on top of us, when we have to do things in a certain way because it's the law, because we're regulated in a business, or just because our business places restrictions on the way we can do things. And we're going to be talking about how we can use generative AI to first start experimenting at scale, then being sure we're able to scale responsibly, and then deploy to production and iterate quickly. And by the time we're done here today, and I only have a half an hour, but by the time we're done here today, I hope everyone will come away with kind of this framework, this pathway in mind. So when we go back to actually deploy these applications, we're going to know how to kind of take it from idea, from experimentation to something that'll actually affect our mission. So I want to touch a little bit about where we are in kind of the generative AI journey and where we see our customers kind of thinking about things, struggling with things, and then most importantly, kind of accelerating. We lovingly call this diagram the swoosh because it kind of looks like a swoosh. But at the end of the swoosh is really when we start scaling, when we start doing things that can have a large amount of disruption. But because we're talking about regulated workloads here, I want to touch on the bottom of this. I want to touch on these bottom layers where we talk about security and governance. Because really, when we talk about regulated workloads, the basis of that is how do we keep our data secure and how do we govern it so we know we're using the data that we have to keep secure and the way we're allowed to use it and the way we're allowed to use it responsibly. In the bottom where we talk about security, you'll hear a lot of people today and in literature and in random marketing things talking about in the media, talking about security and how it's Gen AI is really, really scary in terms of security. The message that I like to talk about with my customers is the way you secure generative AI workloads should be the way you secure any other workload in the cloud or even elsewhere. You need to keep things encrypted, both on disk and in transit. You need to be sure you have authentication in your applications. You need to be sure that that you're running in a place that you're allowed to be running. Maybe if you have government regulations, you're going to be running in a certain instance of the cloud or a certain partition in the cloud. And these are things you need to normally think about. You'll hear terms like prompt injection, where people kind of try to trick models into doing things one way and not another way. Well, prompt injection has a lot of parallels to SQL injection that we were used to dealing with in databases, and some of the guards and some of the guardrails are similar. So we can go back and tell our CISOs and our security people the way we need to think about generative AI is using the same frameworks that we've always used. When we talk about governance, it gets a little different. With governance, we need to say, okay, am I allowed to use this data in am I allowed to use this data in a certain way? Am I allowed to use this data to get out into a certain group of people? Sometimes when you're using generative AI and you're combining different sets of information, those rules tend to change a little bit. It's a little harder to say, if I ask a question and I get something from this database over here, is that really what I'm allowed to see? Or versus going against maybe a traditional relational database where I can say, okay, I don't have access to this stuff. The way to think about that is, and we'll talk about this a little later in some detail, is using guardrails. Is by saying, okay, my boss sees that I'm generating a lot of pictures of corgis, right? Ron isn't allowed to generate corgi pics. I'm going to put a little guardrail in his application saying, if Ron asks for a corgi, just kick him out and say, Ron, get back to work, no more corgi pics. That can be told in the same way for like real life applications, right? Okay, I am not allowed maybe to see data on customers. In our internal systems, we are not allowed to use generative AI to access kind of metadata about customers because that is like our number one priority is to keep that customer data safe. We might put a guardrail on top of our chatbots, on top of our systems that say, you're trying to access customer data, Ron, don't even try it. You probably did this, without malicious harm. This system is not certified for that. And we'll talk about some of those details in a couple minutes. On top of that is the use cases around generative AI. And I'm not going to go through all the use cases and all the kind of where we are in the swoosh, but there's a couple things I want to point out. We hear a lot about chatbots. I walk around, everything's about a chatbot, and chatbots are amazing, right? I can, for example, what I did today when I was preparing this presentation is I recorded my talk and I transcribed it. And I actually uploaded it into a large language model, it was Claude 3 on Amazon Bedrock, and I said, how's my talk? Does it make sense? What do I need to do about it? Does it flow well? And Claude came back with, yeah, you're doing great in these areas, right? It actually said your corgi things are really funny. Good call. I was like, wow, that's some validation, because sometimes I think I'm silly. But it also said, like, I might bring up some details later about different compliance requirements. For example, HIPAA. It said you need to say what HIPAA is, because not everyone else in your audience is involved in healthcare. And I said, that's a really good point. That's really where chatbots can help accelerate us. We deal with lots of executive orders in government, a lot of policy, and these can be really, really long, especially things that come out of Congress and the White House. And I don't know, I'm like, how does this affect me? Well, I can just take that executive order, plow it into my internal doc chat, which is the second thing there, and say, okay, cool. I don't know how this thing affects me. How does this affect my customers in the federal space? What is the preceding regulations? Where do I need to look? That has really saved me all this time and kind of all this cognitive load to help accelerate these applications. But where I think we're going, and if I'm up here talking next year, we're going to be talking a lot about agents and tool use. And that's when I might be saying, okay, I run a supply chain and I need to order blah, blah, blah part. Talking about regulated workloads, maybe this is kind of a sensitive kind of thing. I'm in healthcare and I need to know where my IV bags are coming from. There's a shortage of IV bags, right? How do I determine where to order and where to go? LLMs can actually figure out, based on what we tell it, where to go, which systems to go to, and have me say, I want to order 15,000 IV bags from my hospital or whatever. I know I need to go here and there to try to get those orders based on my regulations. It is super powerful, and as an architect, I kind of abstract that into the data flow diagrams we're used to writing. I can say, okay, this is going to figure out dynamically my data flow diagram. And automatically do it. It's really exciting, also a little bit scary. So let's talk a little bit about filling in that kind of disruption landscape and how we can kind of go and implement that. I talked about experimenting, I talked about scaling, and I talked about production. So experimenting in this world is vital for a couple reasons. One, anybody can experiment. I showed one of these applications to, my mom, a little bit of an older lady, and she was like, oh my goodness. And she called me a week later and said, I had to give this speech someplace at wherever. I use this thing to refine my speech and go. And I'm like, wow, I didn't expect you to take it there. Don't tell her I said that. But experimentation can go to our end users, go to our analysts if we kind of work in that part of the government, go to really whoever else we want to give stuff to, and they can kind of reimagine their mission, reimagine how to do things if we put the right technologies with the right guardrails in their hands. I mentioned these corgi things I'm going to keep coming back to. When we've been generating stuff about corgis, we've hit really weird guardrails in some of these services. I couldn't, for example, generate a corgi with a red cape in one of these models, but I could a blue cape. And it was like a weird guardrail. And you kind of learn how not to get around the guardrails, but kind of how they work, what those limits are, and what you can do with them. Getting experimentation in the hands of people are crazy important, but in a regulated environment, you've got to do it with the right guardrails. When I go to our internal system and, I went to do my speech, there's a big red warning on the top that says, hey, do not put customer data in here, right? This is restricted to this kinds of data. Don't do anything else. You got to get that in front of people and make them understand the risks around using these systems and what you're allowed to do with these systems, which gets into scaling. So when I kind of finish that experimentation phase, I decide, yeah, this is something I want to push to production. I need to get that message out to everybody. I need to tell people that these models hallucinate. They can combine piece of information here, piece of information there, and come up with a piece of information that is completely wrong, right? These things need humans to review them. If I'm generating code, which I do all the time, I don't want to use my code inside of my application without looking at it, without being sure it works, and going. These stuff still need a human in the loop, and it's in the scaling factor, it's important to be sure to train everybody from your sysadmins all the way up to your CEO that these are the ways that we can use these systems. Leveraging the power of the cloud, and I have a big AWS sign in behind me. Like it's not a surprise I'm going to say that, but where we really get that value is understanding that you can inherit all the things that we do really well in the cloud. We can scale, and most importantly, we can be secure. Services like Bedrock, which we'll talk in a second about, enable us to say AWS certified the service to be HIPAA compliant, certified the service to say this is eligible for a HIPAA regulation, eligible for certain financial types of applications, and you can take that and understand that you have to do a lot less work to scale things out. Then you go to production, and when you go to production, the important thing to think about is iteration. Kind of gone are the days in this world, even in tightly regulated environments, where we can say, okay, I have my idea, I'm even going to use an agile kind of methodology, I'm going to deploy something to production on time, and then I'm just going to leave it. This technology changes so fast. Our partners in Anthropic release models like less than once a quarter is kind of their modality, and each one is more amazing than the last. There's other models, lots of other providers out there, and each kind of has its own unique set of strengths, a unique set of weaknesses, and nothing can be stagnant. And when we talk about pushing things to production, we need to measure and measure and measure. We need to understand who's using these applications. We need to get feedback from our users and from our end users. Maybe we can do that automatically using generative AI, really, really cool. But we need to take those learnings and kind of repeat that cycle. Say, I'm going to start experimenting again, and I'm going to push it right through. So when you think about doing things, even in kind of a strict environment, you need to think about how we can move quickly and how we can just go. And of course, the tools can help you with that. Okay, my next corgi here, building a water park. Doing this yourself can be really hard, right? These things scale in different ways than we're used to seeing applications scale. It's no longer easy to kind of say, okay, I have my secure room over here where my whatever regulated data here is. I'm just going to kind of keep it there, slap some Gen AI on top of it, right? These things take lots of resources, and they change very, very quickly. When you talk about GPUs, by the time you land a GPU in your data center and plug it in and secure it and stuff, NVIDIA's already come out with the next one that you need for the latest set of models. It's really hard to keep up, and at Amazon we like to say put that burden on us, right? We can do that at a huge scale, and we can keep up with the latest models. And we do that here through our generative AI stack, and I've seen this in a couple different other sessions in here this morning, so I'm not going to go too deep into some of these services, but I want to point to a couple different places that are important to think about for generative AI workloads. The first on the very, very top are things that all you need to do is make an API call or open up to your users. I'm going to focus in a little bit on the upper left on Amazon Q, and particularly around code generation. That I think if we're here 3-6 months, and I would ask everyone to raise their hand who's a developer and said who has used generative AI to generate code or to help them in their code, everybody should be raising their hands, and if everyone isn't, they're probably a little bit behind the curve. And the reason is these coding companions are so good at taking routine tasks and automating them. So I no longer have to go look up how do I secure this little bit of piece of code here, and how do I, push this piece of code into there? How do I upgrade my entire code repository to the latest version of Java or something? These things can do them well and can do them automatically. And for secure and regulated workloads, that's even more important because you don't want your developers screwing up, right? Because the first time your developer screws up, that's when you have a data leak. So code generation is very, very important. We're here in the Bedrock Hut, the Bedrock Village, whatever this room is called these days. Bedrock's really, really cool. We keep up with a lot of the latest models, and we offer an incredible amount of choice in Amazon Bedrock. So checking my speech thing was done through Anthropic Claude, like I mentioned, but I could have easily said, Claude, I don't like your results. I want to see what Metalllama does. It happens at a click of a button. What I really, really like is that you can measure that. So I say, okay, I'm not quite sure, something new came out. I can hit a button, feed my prompts in, and measure against those results and see what's the best for my current workload. And that is super powerful no matter what result you're in, because if you ever look at these model leaderboards, I mean, it is like you can't keep up with them. They change every 5 minutes. And measuring things automatically and automating things in a service like Bedrock is very important. And on the very bottom of this are what all this stuff is based on. The GPUs through our partners, NVIDIA and Intel and others. We make our own, Trainium and Inferentia, if you've heard of those. If you want to do it yourself, it is a lot easier in the cloud than building things in data centers. I wanted to give a little example of a regulated application, a regulated workload that has gone into production successfully. We at Amazon like to eat our own dog food. So a lot of the services that I mentioned before, a lot of the technologies we use throughout our business. So if you watch Thursday Night Football, it all runs on AWS. If you buy things off of Amazon Pharmacy, it also runs on AWS. And Amazon Pharmacy is a regulated workload, right? They are a medical provider and have to do things in a HIPAA compliant in ways that are compliant to the workload, to the regulations. And they saw an opportunity to automate some of their frequently asked questions. So they got phone calls and chats and stuff from users saying, how do I transfer a prescription? I have this problem. What do I do? Right? And they wanted to make it easier. So if I want to fill a prescription, I didn't have to call. And they can kind of take their existing customer service workforce and make them kind of push them up the stack to answer the hardest task. So they very quickly realized they could improve their experience that way, and deployed a model to Amazon Bedrock. This was Amazon SageMaker, which is our kind of data science service. It was actually pre-Bedrock, and came up with this chatbot that they increased that operational efficiency and didn't have to worry so much about the regulations, because they were using services that were already deemed to be compliant with the regulations. And that's one way, if you kind of leave with one thing besides corgis, is for these regulated workloads, take advantage of the hard work that we've done in security, in making sure they're compliant with various regulations, and use them in your world. You don't have to reinvent the wheel, because we've done a lot of the hard work, just like our friends in the pharmacy business did. So with that, this is my final corgi here. I believe my prompt was corgi in a field with a sign saying thank you, and I think I threw photorealistic in there, so the other ones are cartoons. This is a little fake corgi in a field saying thank you. Here's my email address. You are welcome to call me or email me if you have any questions. I'd be happy to get you in touch with the right people at AWS if I'm not the right person there. And I really thank you. It's a pleasure to be talking to you folks about generative AI. You can hopefully sense some of my excitement. And I'll just open it up for questions. Yep.
Yeah, that's very interesting talk. So thank you very much. About the Amazon pharmacy,
Mm-hmm.
are you able to elaborate what kind of architecture it is? I see
Mm-hmm.
using SageMaker, but in terms of the whole like the documented generation or agent framework, like how you put the things together. This is one question. The follow-up question is what kind of security measure of security controls implemented? So there is the other
Sure. So the question was, what was the? I brought up Amazon Pharmacy. What was their architecture and what are their security measures? I don't have with me the actual architecture around this pharmacy use case, although I could get it for you. I believe there was a blog written on this, although I'd have to follow up on that. What I can tell you is it is a chatbot system, right? And they launched a chatbot model into their environment. I believe I read that it was not fine tuned, that it uses some kind of RAG based system. As far as security goes, I don't know the architecture, but I could get back to you on some of those details if there's things that we release publicly.
So the data goes through Prismatic or
It's it would not be a FISMA system because it's not a federal, it's not a government system, but it would go through HIPAA compliance, HIPAA, which is the healthcare, kind of the healthcare arm, compliance, and as well as our own security measures. Yep, back.
You mentioned measuring results from the
Mhm.
models to compare. How would you measure results for accuracy?
So the question is, how do you measure results for accuracy in chatbot-like systems? Like I mentioned, Bedrock, measuring the measuring service. There's a couple different ways. There's standard measures that you can use that are kind of in different applications. So if you're trying to use for example, a coding companion service, there's data sets with essentially prompts and results that you can run through a system. A lot of times folks that have kind of unique workloads, will provide a set of prompts and answers that essentially you run through a service like this, and it iterates through the prompts and the answers and actually uses large language models on the kind of judging side, right? So it says, okay, here's my prompt, here's my answer. What is does this look like the right answer? And that's a kind of a form of supervised learning, but not really. It's more like supervised judging. I just coined that term, so if you read about it, you'll know where it came. But it's like supervised judging, where it says, okay, I have my set of questions, my set of answers. Let's try to measure whether or not they're the same. That answer your question? Hello.
I'm curious operationally about how to do this without the customer regulations. I work here as a generative.
Mm-hmm.
Situations like inspections or observations, you have to be certain organized, you have to be certain inspection reports, you have to be certain.
Yeah.
Those are all regulated. How could that be facilitated?
So the question is, there's kind of regulations on top of regulations, right? So I talked a little bit about kind of IT regulations where I need to be sure my thing's HIPAA compliant or whatever. You're talking about I have regulations to kind of inspect my business, right? Inspect my, drug manufacturers or whatever.
If we're going to use it as a system, text output has to be
So the text output has to meet a certain format. So what I might suggest there is that would be a exercise in prompt engineering a little bit, right? You would say, okay, here's an example of my output, and my output looks like this. everything has to comply with this output. So whatever you answer me needs to do that. And you would essentially tell the model on the way in, here's an example, here's my schema, here's my question. My question has to be compliant with this schema. Does that make sense? Yep. And I could, if you'd like, I can dive deeper with you as well. Okay. We have, and that's it. That's 2:30 now. So I want to thank everybody for being here today. And I'll stick around if you have any questions. Again, here's my email address, and stick around with my colleagues for the next session. Thank you, everyone.